All right, so I'm going to talk to you about solving exponential equations. And the thing that I want you to remember when you're solving exponential equations is that you have to make sure that the equations have the same base. And so for this first example, it's pretty simple because they already have the same base. So when they already have the same base, that means that you can just set your exponents equal to each other. So I can say that 3 is equal to x plus 1. So if I'm solving for x, I'm going to subtract 1 from both sides of my equation, and I get that 2 is equal to x, which is the same thing as x is equal to 2. Now, if there are ever situations such as this where they do not have the same base, you have to rewrite it so that they do. So what I can do here is I notice that I can rewrite 9. Actually, let me fix that. I'm going to rewrite 9. Let me highlight it rather than scratch it up. As 3 squared. So I'm rewriting 9 as 3 squared. But I can't forget about this 5 that's here. So I'm going to go ahead and put this 5 in parentheses because I need to bring that 5 down. And then I have over here to the left 3 to the power of 2x minus 4, and all of that is equal to 3 to the power of 2 times 5. Okay, so let me simplify some of this because it looks a little much. So I've got 3 to the power of 2x minus 4 is equal to 3 to the power of 10, because 2 times 5 is 10. Now that they have the same base, I can set them equal to each other. So I'm going to say 2x minus 4 is equal to 10. So I'm solving for x, so I'm going to add 4 to both sides. Oops. So this gives me 2x is equal to, not sure where that went, is equal to 14. 2 times x is 14, so if I divide both sides by 2, that'll get me the x by itself on the left. And so then on the right, I'm left with 14 divided by 2, which is 7. So therefore, x is equal to 7. There are also going to be times where you're going to see a fraction. And so what we can do here is we know, and I'll just do this over here off to the right, that 1 over 9 is the same thing as 1 over 3 squared. We also know that if we make this, not sure why that's writing, if we make this negative, if we make this 3 to the power of negative 2, that they all mean the same thing. So, because remember, before when we were trying to make the 3 to the negative 2 positive, we would put it in as a denominator to make it positive. So I can also undo that by putting it on top and making it negative. So that means that I can replace this with 3 to the power of negative 2, and then that's equal to 3 to the power of 2x. So now I can see they have the same base. So since they have the same base, I can set my powers equal to each other. So I'm going to say negative 2 is equal to 2x. And again, I'm solving for x. So I want to divide by 2 to get the x by itself. So I'm going to divide the other side by 2. So when I do that, I have negative 2 over 2, which is equal to negative 1, and that's equal to x. So x is equal to negative 1. The last example I want to show you is that there are going to be times where you're going to have to change both sides, not just one side. So what I'm going to do here is I notice that these are each can be written as a power of 5. So this is the same thing as 1 over 5 cubed, but I don't want my 5 cubed on the bottom, so I'm going to make it 5 to the negative 3rd power. And then 25 is equal to 5 squared, but I can't forget about that 3x that was already there. Okay, so this is 5 to the negative 3rd power is equal to 5 to the power of 6x. So again, now that they have the same base, I can set my powers equal to each other. So negative 3 is equal to 6x. I divide both sides by 6. And so negative 1/2 is equal to x. So x is equal to negative 1/2.